Hello everyone and welcome back to the channel. Today we're going to discuss what I consider to be the most important lesson for 6th graders, and that is the lesson I titled Identity, Equality and the equation ax plus b equals 0. So without further ado, let's just start with the lesson. The first thing we're going to consider is what I call identity, okay? Now, identity is very simple. It means a number is equal to itself, okay? So if I write 8 equals 8, that is an identity. If I write 1/2 equals to 1/2, also an identity. In general, you know that every number a equals to itself. That is the basic principle of Aristotelian logic also, and everybody here knows that mathematics is based on formal logic, right? So I think there are no questions about identity, just the number being equal to itself. Now the next thing is equality. An equality is just a numerical expression which has a left side and a right side, and the left side is supposed to be equal to the right side, right? If I write 3 to the power of 2 plus 1 equals 2 times 5, is this a correct equality? Well, yes, because 9 plus 1 equals 10, 10 equals 10, right? So this is a correct equality. And why is this a correct equality? Because when I simplify both the left and the right side, I can reduce this equality, this numerical expression, to an identity, right? Because 10 equals 10 is an identity. Therefore, I conclude that 3 to the power of 2 plus 1 equals 5 times 2 is a correct equality. If my equality is not reducible to an identity, then I have an incorrect equality. For example, if I write 3 to the power of 2 plus 1 equals 2 times 6, okay? I get 10 equals 12, which is not an identity. And therefore, I can call this an incorrect equality. All right, makes sense? So if the left and the right side are equal, if my equality is reducible to an identity, then it is correct. If it is not reducible to an identity, then my equality is incorrect. I hope this makes sense. Now the third thing I have is an equation. Now the equation is similar to an equality, but the difference is that one of my numbers is replaced with an x, with an unknown, and I need to solve the equation to find the value of my unknown, right? So let's call it an equality in which one of the numbers is replaced with an unknown. I need to solve the equation to find the unknown. Of the unknown variable. So for example, if I have 3 to the power of 2 plus x, x is my unknown, equals 2 times 5. Now this is an equation because I have an x in there, okay? Makes sense? So identity, equality, equation. Now it is logical to ask this question here. Let's put it as number 4. What does it actually mean to solve an equation? Okay, think about it. What does it mean to solve an equation? Well, the answer is to find its root or roots, or to show that there are no roots. Okay, this is what it means to solve an equation. It's to find the root or the roots, maybe there are more than one, or to show that we have no roots, that there is no solution. Okay, now, but then I can ask this question: what is a root, right? What is a root? Well, for example, 3 to the power of 2 plus something equals 10. What should I add to 9 to get to 10? Well, obviously, x should be equal to 1, right? As in my numerical example here, 3 to the power of 2 plus 1 equals 10, right? So I can conclude here that if I have 3 to the power of 2 plus x equals 10, x equals to 1 is a root. The root means it's a solution. How do I know that x equals 1 is a root? Well, because if I substitute the value of 1 in the place of x, instead of x, if I write 1, I'll get 3 to the power of 2 plus 1 equals 10, which is a correct equality. Because 3 to the power of 2 plus 1 equals 10 is a correct equality. So I can answer this question by stating, so answer, the root is a number such that when I substitute its value, for the unknown variable, I transform, let's say it in this way, transform the equation into a correct equality. Okay? In the same example, 3 to the power of 2 plus 1 equal plus plus x equals 10. How do I know, for example, that 2 is not a root? So x equals 2 is not a root because if I substitute instead of x, I have 3 to the power of 2 plus 2 equals 10, 9 plus 2 equals 10, 11 equals 10, right? So this is not a correct, it's an incorrect equality. Something happened here. It's an incorrect equality because it's not reducible to an identity, okay? And this is my structure, so to speak. I have 3 levels. The basic level is the identity, then the next step is the equation. How do I know whether the equation is correct? Well, if I can reduce it to an identity, then it is correct. If I cannot reduce it to an identity, it's incorrect. And then the third step of my structure is the equation. How do I know that I found the solution, the root to this equation? Well, because if I substitute it, I should be able to reduce it to a correct equality. If it's incorrect equality, then I did not find the solution to the equation. Does it make sense? I hope it makes sense. Let's give one more example. So, for instance, x to the power of 3 minus x equals 0, okay? Is x equals 0 a root? Well, let's check it. So 0 to the power of 3 minus 0 equals 0. Now 0 to the power of 3 from the previous lesson, you know, this is 0 times 0 times 0. Obviously, this gives 0. 0 minus 0 equals 0. 0 equals 0. It is a correct, it is an identity. So this is a correct equation. And therefore, the answer here is yes, x equal to 0 is a root. It is a solution to this equation, all right? I can do the same for, let's say, if x equals 1. Let's ask another question. Is x equal 1 a root to this equation? Well, let's make a check. 1 to the power of 3 minus 1 equals 0. 1 minus 1 equals 0. 0 equals 0. It is an identity, therefore the answer is yes. What about minus 1? Is x equals minus 1 a root? Again, let's check it. Minus 1 to the power of 3 minus minus 1 equals 0. Minus 1 to the power of 3, you know from the previous lesson, when I have a negative base to an odd power, I get a negative result. So this is minus 1. And then minus times minus gives a plus. Plus 1 equals 0. 0 equals 0. Yes, so I have also x equal minus 1 is also a root to this equation. So far I found 3 roots. X equals 0 is a root. X equals 1 is a root. And then x equals minus 1 is also a root. Okay? I can check, for example, for other numbers. I can ask, is x equals 2 a root? So 2 to the power of 3 minus 2 equals 0. 8 minus 2 equals 0. 6 equals 0. Not an identity. And therefore, the answer here is no. X equals 2 is not a root. I hope this is clear for everyone. Okay? Let's move on. So this was number 3 of my... Okay, this was number 4 of my plan here. Let's write number 5. Two equations are equivalent if they have the same roots. Okay, this is a definition here. This is a definition. For example, x squared equals 1 and modulo of x equals 1 are equivalent. In both cases, the roots are plus or minus 1. The roots are x equals plus or minus 1 in both cases. I can make a check. 1 to the power of 2 equals 1. Modulo of 1 equals 1. Minus 1 to the power of 2 equals 1. And modulo of minus 1 equals 1. They're both correct. Okay? I can give an example of equations that are not equivalent. X to the power of 3 equals 1 and modulo of x equals 1 are not equivalent. Because the first one has only one root, x equals 1. This is the only root to this one, and modulo of x equals 1 has two roots, x equals plus or minus 1. Okay, so obviously we are considering x to be part of the set of rational numbers. Okay, this is the set that we are dealing with so far at this point. We don't speak about irrational numbers yet, complex numbers, etc., etc. They come much later. We are going to restrict ourselves only with rational numbers at this point. Okay, so the only rational number in the first case is 1, and there are two rational numbers in the second equation, plus or minus 1. So they have different roots, right? They don't have the same roots. These equations are not equivalent. Okay, now let's write as main property I can add, subtract, multiply, or divide both sides of an equation by the same number Obviously, in the case of multiplication and division, this number has to be different from 0. Let's put it like this, different from 0, and I'll get an equation equivalent to my original equation. Okay, let's give an example. So for instance, I can have 2x plus 1 equals 0. All right, now what is the root here? X equals to minus 1/2 is a root, because if I substitute, I get 2 times minus 1/2 is minus 1 plus 1 is 0. Okay, so let's apply a certain action on both sides of this equation, both on the left and the right side. Let's say I want to add 5. Okay, so plus 5. I write this vertical line here, which indicates that I'm going to apply a certain action on both sides. This is my notation here with this straight line, like a module, but only one line. So I get 2x plus 1 plus 5 equals 0 plus 5. 2x plus 6 equals 5. Is it true that I get the same root as before? Well, let's check it. 2 times minus 1/2 plus 6 equals 5. 2 times minus 1/2 is minus 1, so I get minus 1 plus 6 equals 5. 5 equals 5, and I get an identity. So you see that I have the same root as before. The fact that I added plus 5 on both sides did not change the root. So I got this equation here, which is equivalent to my original equation. These are equivalent. And you can test this property. You can subtract a certain number on both sides, you can multiply, you can divide, and every time you'll get an equivalent equation with the same root as the original. Alright, makes sense? Now, this should be 7. The equation a times x plus b equals 0, a different from 0. Okay, This is what later will be called a linear equation, but for now we're not going to call it that, because linear equation implies certain knowledge about a linear function which we don't have yet. We're just simply going to call it an equation of the with one unknown of the first degree, because we have only one unknown. This is x. A and b are numbers which are given in the problem, and obviously x is to the first power, to the power of 1. Okay, so we can call it an equation with one unknown of the first degree. This is an equation of the type a times x plus b equals 0. Now, what is the root of this equation? Well, let's apply the previous property to find the root in the general case. So if I have ax plus b equals 0, what I want to do is I want to have on the left side only x, and my numbers a and b should be on the right side. So how do I move a and b on the right side of this equation? Now, commonly, and I'm going to say it like that, this is a common way of expressing what we're doing. We say we move the number on the other side with opposite sign. So instead of having ax plus b equals 0, I have ax equals minus b. The b goes on the right side with a minus, with opposite sign, okay? But technically, what we're doing actually is we are going to subtract b from both sides of this equation. So I'm going to subtract b on both sides, and I get ax plus b minus b equals 0 minus b. This will cancel, and I get ax equals minus b. Okay? Now the same procedure applies with a. A is with multiplication on the left, so we say usually, common language is to say I move it on the other side with opposite operation division, so it will become minus b divided by a. But technically I just divide both sides by a, so I get a is different from 0, so I get ax over a equals minus b over a and a will cancel, and finally x equals minus b over a is a root. Makes sense? Let's see a concrete example. So for instance, 3x plus 1 equals let's say 9. Okay, I'll be technical here, but later in other examples I will not be technical. I'll just say I move 1 with minus on the right. So, but in this example I'll be more technical. So minus 1 plus 1 minus 1 equals 9 minus 1. 3x equals 8. Divide by 3. 3x over 3 equals 8 divided by 3. X equals 8 over 3. And this is my root here. Okay? Now, another thing I wanted to discuss, let's put it here as number 8. How many cases I can have in terms of the possible solutions to my equation. So let's call it 3 cases of possible solutions to the equation ax plus b equals 0. So the first case is if a is different from 0, what we discussed, x equals minus b over a, it's one root. Okay, only one root here if a is different from 0. But what happens if a and b are both equal to 0? So if a equals 0 and b equals 0. So what I have is 0 times x plus 0 equals 0, 0 times x equals 0. And now, how many roots do I have in this case? Now, let's start checking. For example, is 1 a root to this equation? Well, if I substitute 1 instead of x, I'll get 0 times 1 equals 0, and this is correct because 0 times 1 is equal to 0. That's right. So 1 is a root. It's a solution to this equation. What about if x equals 2? So let's check again. 2 times 0 equals 0. That is also correct. So 2 is also a root to this equation. In general, you can see that I can choose any number for x, and when I multiply it by 0, I'll get 0 and I'll have a correct equality. So I claim here that every rational number will be a root to this type of equation. So the answer here is I have infinitely many roots, infinitely many roots, and technically I write the answer as x belongs to Q, where Q is the set of rational numbers. That means every rational number will be a root to this equation. 0 times x equals 0. Okay? Now the third option is if a is equal to 0 but b is different from 0. So for instance, 0 times x minus 1 equals 0, or 0 times x equals 1. Which number can I choose instead of x so that when I multiply that number by 0, I'll get 1? Well, if I choose x to be 1, 0 times 1 will be 0, it will not be 1, and so on. So there is no number which, if I multiply it by 0, will get to 1. So there is no number that will make this type of equation into a correct equality. This will always be an incorrect equality. It will be 0 equals 1 for every single number that I can choose for x. So this equation has no roots. No roots. And technically I write it as x belongs to the empty set. Okay, this is the empty set. The empty set means the set which has no numbers. So there are no numbers that can be solutions to this equation. All right, and these are my three possible cases. If a is different from 0, 1 root. If a and b are both 0, infinitely many roots. If a equals 0 and b is different from 0, no roots to this equation. Okay? Well, that's basically it. Let's jump into some examples. Okay, as usual, we are going to use our collection of problems from our favorite hero, Kosta Kolarov. He has the best problems, I told you last time. So we are going to go to page... This is page 10 of this textbook collection of problems, and we are going to solve from 76 to 81. All right, and we have the answers here. So the first one, we should get 6. Let's see if we can solve this and get 6. I'll copy it real quick. Now the first thing to do in these types of equation is to find the common denominator on both sides in order to remove the denominator. Okay, so I see here that I have 2 and 5. The common denominator of 2 and 5 is 10. So what I do is I multiply by 10 on both sides. Okay, and I'll get an equivalent equation to this one. So the first term here, I just multiplied by 10, I get 30 y plus 1. And then the second term I multiplied by 10, but when I multiplied by 10, I cancel the 10 with the 2 in the denominator, so I'm just left with I'm left with a factor of 5 to multiply the numerator, right? So I get minus 5 times 10 minus y. Again here 10 and 5 will cancel, and I'm left with a factor of 2 for the numerator, 4y plus 11, and then plus 120. 10 times 12 is 120. I have no more denominator, all right? And now I just open the brackets. So 30 times y, it's 30y plus 30, minus 5 times 10 is minus 50, plus 5y, because I have minus times minus. This equals to 8y plus 22 plus 120. And now I move all my variables on the left, all my numbers on the right. So this is 30y plus 5, this is 35y. Then this 8y will go on the left side with a minus, because I'm subtracting it from both sides. So minus 8y equals to 22 plus 120 is 142. These numbers go with opposite sign, minus 30 plus 50. So I get 27y equals to 162. So I divide both sides by 27. I get that y equals 162 divided by 27. And this should be 6. Okay? Makes sense? Let's go to the next one. Okay, I copied the equation real quick. The same procedure as before, the common denominator of 2, 5 and 7, these are prime numbers, so I just need to multiply them. 2 times 5 is 10, times 7 is 70. Multiply by 70 on both sides, cancel the 7 with the 70, I get 10 times 6x plus 7 plus 70x equals, cancel the 70 with 5, I get 14, 80 plus 4x, and minus 35 times 30 minus 2x. Okay, remove the brackets, 60x plus 70 plus 70x equals 14 times 8 is what? 80 plus 32, 120 plus 56x minus 1050 plus 70x. Okay, so 60x plus 70x minus 56x minus 70x, this will cancel, equals to 1120 minus 1050 is 70, and this 70 will go with a minus, so 70 minus 70, and I get 4x equals 0, and therefore x equals 0. All right, so 2, 3, 3, 6 multiplied by 6 on both sides, by 6 here on both sides, 2x minus 3 plus 3x plus 3 minus 6x equals 5 times x minus 1 minus 2, 3x minus 4. Okay, remove the brackets, 2x minus 6 plus 3x plus 9 minus 6x equals 5x minus 5 minus 6x plus 8. So here if I add this, I get to 5 minus 6 is minus x. Then here this goes with opposite sign, so minus 5x plus 6x equals to 6 minus 9 minus 5 plus 8. Okay, so minus 6 plus 6, 0 times x equals to 6 plus 8 is 14, minus 5 minus 9 is minus 14, so 14 minus 14 equals 0. 0 times x equals 0, and therefore x belongs to Q. Okay, every rational number is a solution to this equation. Common denominator 3, 4 and 8 will be 24. So here I have 8 times 5x plus 21 minus 48x equals to 6 times 4 minus 3x plus 3 times 8x plus 62. 40x plus 168 minus 48x equals to 24 minus 18x plus 24x plus so this will be 186, right? So here I get minus 8x, here I get plus 18x minus 24x equals to 24 plus 186 minus 168. So this is minus 14x equals to what? Now, so 186 minus 168. Okay, let's just sum these two first. So this is 210 minus 168. So this is 42, right? 42. So minus 14x equals 42. X equals 42 over minus 14, which is minus 3. Okay, and that's the answer. So common denominator 3, 4, 5 and 6, this will be 60, right? By 60. So here is 10, here is 60 divided by 4, 15. Here I get 12 and here I get 20, right? So 5 times 10, this is 50, x minus 18, the numbers are getting bigger and bigger, minus 45 x minus 6 equals to 48 x plus 4 minus 40 x plus 12. Okay, so I get 50x minus this will be what, 900 minus 45x plus 45 times 2 is 90 times 3 is 270 equals to 48x plus what is this, 8 times 4 is 32, 2 and 3, 4 times 4 is 16 plus 3 19, 192 minus 40x minus 4 times 12 is 480, 48 with a 0, 480. I have barely the space to write everything. So 50 minus 45 is minus 5x, plus 5x, 5x. So I have here, this is going to be plus 8, right? If I subtract them, on the other side will be minus 8. So minus 8x equals to, then I get 900 will go with plus, 270 will go with minus, 900 minus 270, and those on the right will stay the same because I'm not switching them. So plus 192 minus 480, plus 192 minus 480. So this is minus 3x equals to, wow. Now if I do this two first, so this is 600, 750, so 900 minus 750 is what, 150, 150 plus 192, this is 200, 342, x equals to 342 divided by minus 3, this is minus 1, 1, and 12 minus 114, and that's the answer. Common denominator is 12 multiplied by 12, 12 minus 2, 3z minus 5 equals to 3 minus 2z, 12 minus 6z, plus 10 equals 9 minus 6z. This goes with plus 6z minus 6z equals this go with minus 12 minus 10, so 0 times z or z, whatever you prefer, equals to this will be minus 22 plus 9, which is going to be minus 13, right? Minus 13. And now which number do I multiply by 0 and get to minus 13? Obviously there is no such number. Z belongs to the empty set. Okay, well, I hope you found this lesson instructive and it gave you a better understanding of what it means to solve an equation, what is an equation. If you have any questions, let me know in the comments below. If you enjoyed this content, like and subscribe, and I'll see you in the next one. Bye for now.